The command line brought software you had to learn. The graphical interface introduced software you could see. The touchscreen brought software you could feel. What's the next step for user-facing components in software development? Every one of these eras made software both easier to reach and easier to operate. Each of these eras gave you a new way in, however, none of them actively took the user into consideration as they operated software. Why, in an age full of cutting-edge technology, do the websites and apps we all use every day have to be static when human headspaces are so dynamic? There hasn't yet been a solution that changes the user's experience according to behavior while understanding cognitive state, because nobody's been able to solve how to infer user state without outright spying on the user. We built the first framework that makes web apps conform to your behavior to boost your productivity and make sure you get the most out of your experience on a vendor's app. We called it the Dynamic UI Morphing Framework. We aim to take the next step in software development by overseeing a user-centric approach without invading privacy. The framework is a business-to-business solution that transforms static interfaces into dynamic platforms that users don't just work on, but rather work with. We achieve this through an ecosystem powered by two agents. First is the developing agent. Before a single user ever touches the product, the developing agent runs. First, a vendor hands the developing agent their codebase for a given app. Then, they provide the agent their own instructions and guidelines. Upon execution, the developing agent returns the codebase with the vendor-requested UI layouts implemented inside of it. The new codebase is now capable of changing shape live. Once the app is live, the behavior agent watches the user's behavior to look for behavioral signals passively. In our example, these signals are window focus and blur, action timing, error and correction rate, scroll patterns, cursor dwell, and navigation revisits, along with a few others. The behavior signal is structurally incapable of reading keystroke content, form values, or on-screen text. Since behavior differs largely from user to user, each signal is evaluated against an individual user's own historical baseline rather than a universal threshold. This is the app in normal mode, the default state before any behavioral signal has pushed it anywhere. Everything you'd expect from a standard dashboard, no adaptation happened yet. Now I'll switch manually between modes. In production, this happens automatically. I'm just triggering it manually so you can see the process in action. Watch what happens in focus mode. Menus collapse, the sidebar is gone, only the current task remains. The system switches to this when it thinks the user has lost focus. Exploration mode reads the opposite state. The system thinks the user is lost and so provides more tools and context surface for guidance. And clarity mode, for fatigue, simplifies things further. But how do we build user profiles without crossing the line into surveillance? Our system is physically blind to text content, clipboard data, and form values. It operates exclusively on numeric telemetry, click frequencies, dwell durations, scroll reversals, error rates, etc. These passive signals are normalized against each user's unique historical baseline using localized z-scores. We don't track who you are. We track how your patterns deviate from your own normal behavior. When taking human behavior as input in any software solution, there arises a very common question. What happens when the system guesses wrong? How do you handle false positives? We solve this through architectural constraints. Our system doesn't let one noisy signal change the interface. At least two signals have to independently cross a z-score of 1 before a switch is even considered. Co-occurrence is another safeguard against false positives. Another factor that blocks false positives is how meticulously the signals are selected. Every mode switching decision runs through hysteresis on purpose. Switching into a restrictive mode requires the score to cross plus 1.8. Switching back out only requires falling below plus 1.2. That gap exists so that the interface never flickers on a borderline reading. Every switch is followed by a hard 120-second cooldown before another one can fire. Furthermore, nothing acts on a single anomalous reading. A signal has to hold, sustained, for minutes at a time, not seconds. Math that runs live every session on every user is simple deliberately because the hard thinking already happened once before any user ever showed up. That's the developing agent's job. It reads a vendor's unfamiliar codebase a single time and decides what focus mode should even mean inside that specific app. After that, the system isn't reasoning anymore. It's just checking numbers against a vendor-defined threshold and switching UI layouts accordingly. This is why it can run fast, light, in the same way every single time. Once again, address any and all privacy concerns. All of this runs entirely in the browser. No raw event stream, no keystrokes, no clicks, no mouse path is ever sent to a server. The only thing that ever leaves the client is an aggregated statistic the mean and standard deviation per signal, and only with explicit vendor and end user consent. Clipboard content is never read. Keystroke content is never captured. The system may know that you paused, but will never know what you typed. This isn't a privacy disclaimer added on at the end to fulfill requirements. It's the constraint the entire architecture was built upon from the first signal we chose to the last line of the scoring algorithm. The Dynamic UI Morphing Framework doesn't need to watch you to understand you. It just needs to notice the difference between you and you on a hard day.